Okay, here we want to use the first derivative test to find our relative maximum and minimum of a function. All right, we can use this to graph, we can use this to evaluate, but remember, we have to make sure that we stay disciplined and we stay in order. The first thing we want to do is always set our first derivative equal to 0. That's going to give us the critical points. That's the most important part of this problem, the critical points. Then we're going to set up a number line and use the test values on both sides of the critical points. If it's the first derivative is positive, then the function is increasing. If the first derivative is negative, then the function is decreasing. All right. Then we plug our critical points back into the original function. And when we use that along with our number line, that's going to tell us if we have a relative minimum or a maximum value. I did the video before, and that's going to show you how to graph it and things like that, but I want to just concentrate on this now. So the first thing we want to do, we want to set the first derivative equal to 0. So that's going to give us 3x squared minus 6x is equal to 0. Of course, we know that the derivative of 3, the derivative of that constant, was just 0. So now we have, sorry about that. So now we have 3x squared minus 6x is equal to 0. All right, so now we want to take it all the way back. We want to factor out the greatest common factor, which is going to be what, 3x. All right, so that's going to be 3x, and then x minus 2 is equal to 0. All right, so now we set both the product equal to 0. So that means if 3x is equal to 0, then x is equal to 0. And if x minus 2 is equal to 0, of course, we add 2 to both sides, and x is equal to 2. So these are our critical points. These are the most important parts of this function, because it's kind of going to guide us and tell us what we need to do and kind of shape that graph. All right. So now we've got our critical points, and what I want to do is set up the number line that we were talking about. All right, so we're going to set up this number line, and we're going to use 0 and 2, our critical points. Okay, so now this is where we want to use our test values. And I'm going to use a different color for our test values. I want to use any number smaller than 0. Yeah, it could be -1, -2, -5, anything smaller than 0. It's going to be consistent. And I want to plug this back into our first derivative. I'm going to plug it into the already factored version. All right, so be careful right here. I'm going to just use -1. 3 times -1 is a negative number. It's -3. And -1 minus 2 is -3. But as we know, a negative times a negative is going to give us a positive. All right, so now let's plug in any number between 0 and 2. Remember, these are the test values. All right, over here, matter of fact, I'm just going to put a -1 out there. We use a -1 right here. Just let's use a +1. That's the number that's between 0 and 2. Let's plug it back in. 3 times 1 is 3, but 1 minus 2 is -1. Positive times a negative is going to give us a negative. So any number between 0 and 2 is going to give us a negative. And now we want to choose any number larger than 2. Yeah, you can use 2, 3, 4, 8, 100. It doesn't matter as long as it's larger than 2. But once again, let's plug it back into the first derivative. 3 times 3, that's a positive, that's 9. 3 minus 2 is 1. The result here is going to give us a positive number. So once again, this will be positive. Now, that seems insignificant, but it's not insignificant at all because that tells us how the graph is going to go. We know that this graph is going to increase from negative infinity all the way up to 0. And also from 2 all the way to infinity. Let me come back and put my numbers in. I mean, my infinity signs, I'm sorry. So from negative infinity to 0, and also from 0 to infinity, this is going to be increasing. Okay, but it's going to be decreasing from where? And we can look right here and see. From 0 to 2. Why is it decreasing? Because it has that negative in the middle. So even though it seems, it doesn't seem very significant, it is. All right. So it's increasing from negative infinity to 0 and 2 to infinity. It is decreasing from 0 to 2. And now this is the important part. If something is increasing, it's going up to a certain point. See, it's going up and then coming back down. So it's going to be increasing until you get to 0. And we have to plug that number back in. That's where we go to number 3. Plug the critical point back into the original function, f of x. So let's look at this critical point. It's 0. 0 cubed minus 3 times 0 squared. That's 0 minus 0 plus 3. That's going to give us a relative maximum at where? 0 and 3. Why is that? Is because it's going up. Now, we're going to have a relative minimum at 1, and now we plug a 1 back into our original. I'm sorry, now we plug a 2 in. I was looking at that because 2 is our critical point. 2 cubed is 8 minus 3 times 2 squared. That's 8 minus 12, which is negative 1, and negative 1 plus, I'm sorry, that's negative 4. I'm messing up. 8 minus 12 is negative 4 plus 3, which is negative 1. So we have our relative minimum at 2 and negative 1. I'm going to repeat that again. That's 2 cubed, which is 8. 8 minus 12 is negative 4. And negative 4 plus 3, which is negative 1. I apologize for that. But yeah, that's what we have our relative maximum and minimum. Of course, we can graph from here. Remember, the critical points kind of give you a guideline for everything we're doing. All right, and that's how we use the first derivative test.